Semiconductor industries evolve in phases. The first phase is driven by device innovation, the second by ecosystem development and process stabilization. Eventually, large-scale commercialization depends on manufacturing standardization, testing scalability, and connected data infrastructure. Silicon photonics is now approaching that third phase. Some standardization exists. Layout formats like GDSII, S-parameter representations, and process design kits, PDKs, have given the design side a workable foundation. But the standardization begins to break down as soon as the device enters manufacturing and testing. Different tools, different vendors, different teams generate data that rarely connects cleanly across the manufacturing chain. This creates what many companies now describe as a broken digital thread. The genealogy of the device becomes fragmented as it moves from design to fabrication to wafer test to packaging to final test to deployment. When a die passes wafer testing but later fails as a packaged optical module, correlation becomes slow, manual, and heavily dependent on tribal engineering knowledge. In heterogeneous integration environments, where photonic dies, electronic ICs, chiplets, advanced substrates, and optical interfaces must all be correlated within the same manufacturing genealogy, this challenge becomes even more severe. And it hits the bottom line directly. Semiconductor testing is typically about 10% of component costs. In silicon photonics, testing can be anywhere from 60% to 90% of product costs. Connect optical, electrical, process, and alignment data into a unified digital thread designed for faster yield learning, root cause analysis, and scalable manufacturing. Visit yieldworks.com to learn more.